Good evening, everyone. My name is Gloria Darko, and I'm an admission counselor at Susquehanna University. We're glad that you all took time out of your evening to join us tonight for our academic panel. Just one housekeeping note is that if you want to ask a question, which we highly encourage you to do so, please utilize the chat feature, and we will keep an eye out on it to be able to answer your questions. And so I'll let Dr. Zain take it away, as well as the rest of our panelists who will introduce themselves.
Thank you, Gloria. Hi, my name is Samya Zain. I'm the head of the physics department and also the advisor for the 3-2 program, which includes chemistry, math, physics, and computer science. So if you have any questions about that, I'm the person to go to. And if you have any other questions after this, you can always ask me. So I'm going to pass off to Dr. Faust, who's also a faculty in the physics department.
Hi guys, my name is Carl Faust. I'm an assistant professor here in the physics department. This will be my 7th year here. And so obviously we have lots of different kind of variations in the physics department. There's a 3-2 program in physics. And so obviously there's a bunch of questions, so feel free to ask us. And if anything comes up, you can certainly contact us at any time. Thanks.
Hi, my name's Dr. Carter. I'm also a physics professor. This is my 2nd year here. I also teach the astronomy course and am getting the astronomy program going here at SU, taking out the telescopes whenever I can. Thanks for joining us, and I'll pass it off to Alex.
Hi, I'm Alex Wills. I'm the head of the Math and Computer Science Department, and I've been at SU for, I guess, going on 18 years. So there we go. I guess next we're going to go to Dr. D.
Thanks, Alex. Hi, everyone. I'm Bill Dougherty. I'm an associate professor of chemistry. I've been at Susquehanna now for 8 years, so I'm here representing our chemistry and biochemistry programs. So if you have any questions on those two, don't hesitate to ask. And now I will turn it over to some of our student representatives.
Derek?
Hello, everyone. I'm Derek. I'm a senior in the 3-2 physics program. I'll be applying to Columbia actually 6 weeks from today, which is exciting and nerve-wracking and all that stuff. So, yeah. And then I'm going to pass it off to Amanda.
What's up, guys? I'm a sophomore. So I'm in my 2nd year of the program. I'm physics 3-2 engineering, and I'm also in the ROTC program here.
Hi guys, I'm Michelle. I'm a junior and I'm a physics major, not 3-2.
So apparently Harim's having some trouble logging on. So he's just going to be right here introducing himself from this chair. I'm going to get up. Come here.
Hi, everybody. I'm Harim. I'm the first graduate from Susquehanna for the 3-2. I just finished my degree at Columbia. So if you have any questions, let me know about the 3-2. I was a physics major at Susquehanna.
Okay, well, exchanging chairs again. I don't know why your thingy is not working, but that's okay. So are we missing anybody that we have not introduced yet? Okay.
So I think as Gloria said, you guys can type stuff into the chat, and if you do that at any time, we'll be able to read that and answer your questions. Maybe in the meantime, should we say a little bit about what kind of classes you'll be taking when you get here for the various majors?
That's a great idea, but can you also in the chat just mention what your interests are, what you're leaning towards, so maybe we can address those as we go?
Yeah, if you have a question for a specific person, feel free to say that. So maybe I'll start a little bit for physics. In the physics or 3-2 program, regardless of whether you come in as one or the other, in terms of the actual classes that you'll be taking are pretty similar, although there are a few extra requirements if you're in the 3-2 program. But in general, usually for the first semester or so, there's a few kind of lab-based introductory classes. So we have a class called Independent Thought in Physics, as well as Digital and Analog Electronics. And those are very hands-on experiences. So those are a lab twice a week. So like Tuesday, Thursday, 1 to 4, that sort of thing. And those are sorts of things where you get to jump into a lot of the content that you'll see in like Intro 1 and Intro 2. So like projectile motion, energy, all that sort of stuff. And then also a little bit more of like electricity and circuitry and things like that in electronics. And so you get to experience that sort of content, but in a more lab-based scenario. And so you'll learn a lot about, keeping a good lab notebook, writing up reports, things like that, and working together in a lab setting. And then obviously we have our introductory physics 1 and 2. If you're in the 3-2 program or physics or chemistry, you'll have to take calc-based physics. I don't think any of the majors in here would be taking the algebra-based, but there's calculus-based physics, and so you'll be taking that for your fall and spring, and that's also has a lab component with it. And then finally, sort of the more potentially exciting stuff are upper level classes. So we have things like quantum mechanics, thermodynamics, mathematical physics. We have modern physics, Newtonian mechanics, electricity and magnetism, and waves, which is a class that's specific requirement for Columbia. So a sort of a big kind of breadth of classes that you can take. And then sort of sprinkled in there are some requirements that go along with your general requirements that we call our central curriculum. So there are things like writing intensive and oral intensive. So you can learn how to, present and write in the context of a physics or a science class, as opposed to maybe just a standalone kind of speech class, things like that. Cool. I'll, if somebody else wants to jump in and answer that. Luca here asks a question. I'm from Lancaster, PA, and interested in studying CS or physics engineering. So maybe Alex, if you want to talk a little bit maybe about CS.
Okay, sure. So we have actually two slightly different CS majors, one leading to a BA, one leading to a BS, as well as the Physics 3-2 program. Pardon me, what am I saying? The Computer Science 3-2 program. For all three of these, normally you'd start off taking a course called Principles of Computer Science, which is really a first serious course in programming. You'd start off learning, well, lately we've been using Python. So you learn Python and you learn the basics of how you go about writing good and effective code. That would be followed by data structures, which is a natural follow-on course, essentially a second course in programming. And then on from there, you've got courses in computer organization, you've got upper level courses in things ranging from compiler theory, which is one of our capstone courses, to machine learning. We've got actually a sort of data science concentration that a lot of students lately have been drawn to, that focuses heavily on things like data mining and machine learning. A kind of bridge course between the upper level and the introductory courses is a course called Algorithms, which gives you sort of the mathematical fundamentals about how you structure and how you analyze, well, algorithms. So maybe that's okay as an overview.
Also, additionally, you could do a double major as well, physics and computer science and or math. Or Michelle, you're now a physics and biomedical sciences, right?
Biochemistry.
Biochemistry. So
yeah, which you can't do 3-2 with biochem, but you still can do physics. But when you add in that other major, you'd have to complete it in 4 years instead of 3. So just keep that in mind. If you're adding on a second major, it might take 4 years. But I'm pretty sure that that's okay with the program. Dr. Zain, yeah.
Yes, absolutely. You'll still be called a 3-2. You'll finish in 4 years.
And it might also be worth pointing out that we do have people every now and again, it's not really all that uncommon for people to triple major. Like Hassana did that recently, for instance.
So we talk a little bit about chemistry quick, and then we'll jump to this question here.
Sure. So in our chemistry and biochemistry program, we have 3 different tracks, all that lead to a BS in either of those 2 disciplines. We have our straight ACS, American Chemical Society certified chemistry track. We also have 2 different biochemistry tracks. We have a biology-focused chemistry track, biochem, where you substitute some upper-level chemistry courses for some upper-level biology electives. This is a good track for students that might be interested more in the medical side of things, but are still interested in the biochemistry. And then we have a more chemistry-focused biochemistry track, again, where you would then substitute upper-level chemistry courses for your upper-level biology electives. All 3 of our tracks have a large research component. So all of our majors are required to do research in their junior and senior year to graduate, culminating in some sort of thesis work for their capstone. So that's something that we really push, and as well as the other departments as well. Something that we really push in the chem and biochem majors is access to research.
So the question is that what is the guarantee of admission to Columbia if you start at SU? Well, it's pretty much guaranteed if you maintain a GPA. That's pretty much what is required. You get no grades lower than a B in any of your math, physics, or required classes. You maintain about a 3.5 or above, and you're pretty much guaranteed into any field. With civil engineering, so there are certain majors that we recommend for students to major at here before they move on to Columbia. So civil engineering will be a major that lends well to physics, being a physics major at SU. There are others that lend well to other fields like computer science. For example, electrical engineering would be one where we would say, hey, you might think of a computer science as a major, but for civil engineering, it's pretty much physics that we would recommend, probably with a minor in math, or if you're doing it in 4 years, it would be a major, like a math major with a physics major would be the recommendation. The question was, the program may become a 4-2 with him. Yes, and that is okay. In fact, for the program, we actually have last year, the students that went were all in his class and the one behind him, they all went in 3 years, but the class after that actually had somebody who graduated in 4 years, is at Columbia right now. Actually 2 of them, right? One went to WashU and one went to, right? Correct me if I'm wrong, I think I'm right. One went to WashU 4 years and one went to Columbia, and they are doing fine as far as I know.
And we do have athletes in the 3-2
Yes.
program right now, more than one, multiple. And the ROTC program is also very demanding.
So there is one person who actually was an athlete, did finish in 3 years, and is at Columbia right now. Other people, like this one, was recruited for the tennis team, played for a week and said, nope, can't do that. So quit the team. And the coach still looks at me funny every time I see him. He's like, you cost me a player.
No, I saw him today.
Yeah, he sees me every time and he goes, you cost me a player. But yes, again, it depends on how many years you want to do it in, 4 and/or 3, which depends on what your progress is going to be. We right now have people in the 3-2 that are actually finishing in 4 years, and that is okay. And Amanda, you can talk about ROTC. with 3-2?
Yeah, absolutely. Sorry, speaking of that time management, I'm currently at an ROTC event. So lean do have things to do. Everyone is super understanding of that, especially in the physics department. You can ask Dr. Zain all the time. She's asked me about PT, and all having a good time with that. We're all super supportive of it. I am personally finishing my program years of the way the ROTC program works, years to complete.
Amanda, you're cutting off.
I'm going as well as 2. The time. Oh, sorry, the Wi-Fi is real bad. Can you hear me now? Okay.
That's better.
Okay.
Now don't move from here.
So just kind of understanding how to manage your time is important, writing a schedule and things like that, but it is definitely manageable. I've done it for almost 3 semesters now. So it's definitely something that you can, all of the professors are super understanding for that. So, yeah.
Derek, could you also address that? Because you played rugby, right?
Yeah, so I mean, you just got to figure out what you want to prioritize. So like, do you want to just like study, play rugby, go to bed, wake up, do it all over again? Or do you want to have free time? So that's basically it. I know the baseball team here is really good. So I understand I understand the hesitation with switching to a 4-2, especially with baseball, because I know those guys have like 3-hour practices, and it's like, that's a huge time commitment. It's not just like in and out. So that would definitely have to be something that you would have to consider, that your son would also have to consider, because I think it's the mom that's here, right? Yeah, or dad, one of the parents. Yeah, so if he decides to go to 4-2, that's fine, because I mean, it cuts out the workload. You can still play baseball, but I mean, I've done it, and you just gotta prioritize. Like, I'm gonna study, I'm gonna go to practice, I'm just gonna do it all over again. You can do it. You can manage it. I mean, it's a lot at first, but you get used to it. So you can definitely handle it.
Yeah, I think I would say, as far as the switching to a 4-2, that I believe, as far as Columbia and the other two, Case Western University and Washington University, I believe all they care about is that you completed your requirements here and attained the GPA requirement, and you know, got the grades and all that. So really the downside is, you know, paying an extra year of tuition, right? So because obviously, you know, that's then 6 years, but you know, potentially your sanity of having, you know, not having your 4 years compressed into 3 while also doing athletics and other things is, you know, that might be worth it, right? And especially if that means that you're going to do really well in your classes as they're spread out over those 4 years. So if you have any other specific questions about that, feel free to follow up in the chat here. Noah asks, I'm interested in a career in architecture. Would engineering be a good path? I would say certainly, yeah. That's definitely a place that you can jump in. I feel like certainly physics is a good kind of starting point for a lot of stuff. And I think if you look at the 3 schools that you can like jump onto after SU, Case Western, WashU, or Columbia, you'll see there's a whole selection of various types of engineering that you can do after you leave here. And so you'll
I don't think architecture is one of them, though.
Yeah, I'm not sure architecture specifically, but things
civil
like
engineering,
structural
yes.
engineering, civil engineering.
Yes.
Those
Civil
sorts of
engineering is there, biomedical, mechanical, all of those. I don't know if we have architecture, specifically architecture.
Yeah, specifically architecture. But again, like those.
Isn't at Columbia, does the civil engineering department also do the architectural thing? No? Okay.
It's all engineering based.
I think, again, I think there's ways you could, you know, that you can make a physics or engineering degree work for, you know, various things that you want to do.
I think it could be especially true at SU. One of the things that's important for architecture is also a bit of an eye for art and design, which is something we really do support here at SU with all of the common curriculum requirements. It wouldn't be a major challenge to also touch in on the other aspects you would need for architecture beyond being able to do the math, understand stress and strain, and how elements interact with each other.
I guess maybe while we wait for questions in the chat, should we say something about like how the central curriculum works a little bit? Because I think our central curriculum is a little different compared to some other schools. Obviously, SU is a liberal arts school, so we sort of value the idea that you kind of get somewhat of a well-rounded education. So you're not just going to be taking physics, chemistry, math, computer science classes. And so, you know, while you're here, there's a whole separate set of requirements that we call our central curriculum. And those involve things like social interactions that might be sociology, psychology, things like that. Literary expression that are, you know, oftentimes English or courses like that. But a couple things that are kind of unique that I think are valuable are things like our intensives, like writing intensive, for example. At least when I went to college, a lot of times the writing classes that I took were like English composition, and they were specifically, you know, talking about writing, and that might be like analyzing poetry or something like that. And that's for some people, but certainly not for me. And so these writing intensive classes that are oftentimes housed in your major let you, like I said earlier, you know, learn how to write and communicate well with other people, but in the context of, you know, the sciences and things like that, so that you're ready for, you know, potentially writing papers or presenting at a research conference or something like that. Let me think what else. Any other things that we should mention about like central curriculum?
Oral as well. The oral intensive, I think that's very unique because we always do those as part of our classes instead of just, sometimes it's only like the senior class or something that they do one presentations. With at least our curriculum in the physics department, it's incorporated into pretty much every single class, right? Any upper level class that you do will have an oral speaking component. Like I'm making these poor kids in my thermal class present, you know, an entire class that they have to come up with, right, you guys? Amanda?
Yeah, absolutely. So excited.
So that means you're going to leave SU with a great deal of confidence in your ability to communicate complicated things to your peers.
Yep. And I think Michelle is doing an internal combustion engine. And
this is true.
Yeah, and so and Amanda is doing a Stirling engine, and they have to put in examples and an actual lecture and an example, like the thing that's moving and stuff. So hopefully it'll be a good experience for them. Okay, so then the next question is that there is a liaison, professors help balance work and needs. Yes. So we do have a liaison between the coaches and the professors, but most of the time, at least for our department, I mean, you guys can just come talk to us. We're pretty, right? That's true, right? Chemistry, physics, math, like we're all pretty flexible, especially in terms of our lab requirements and stuff. And we understand that students can't be there all the time, right? So I don't think that has been a problem for any of our situations. Correct me if I'm wrong.
I agree. I think that the professors here are very accessible.
Yeah, I agree as well.
Oh, yeah, so that shouldn't be a major concern that you know, but we do have one on campus. Hi, there's somebody here. Do you want to introduce yourself?
Sure. Hi, everybody. Sorry I'm a little late. I had another meeting before this, but my name is John Morris. I'm a computer science physics double major, and I'm in the class of 2022.
Can you talk about your story a little bit? You started off as a 3-2.
So I started off here as a 3-2 computer science only major, and you know, throughout the Columbia requirements and things like that, I kind of found another love for physics, and I started getting more and more interested and involved with the physics classes, and I found myself really wanting to stay and complete a physics major. So as of this year, actually, this semester, I became a double major, and I'm really excited about it.
And you're going to finish it in?
I'm going to finish it in 4 years. So Columbia and the 3-2 program itself has an option where you can do 4 years here at Susquehanna and then 2 years at Columbia, or whatever engineering school you go off to too.
So that's another thing that you guys might want to know. Like if you sign up for 3 years and you decide almost at the end, right, that no, I want to stay another year, that's always an option. The only thing that really prevents you from getting into Columbia is your GPA. That's pretty much it.
as long as you keep that GPA up there, you're good. Yeah. Absolutely.
Yep.
We have a lot of support systems to help students maintain that GPA. Would anybody like to talk about some of their experiences with our Center for Academic Success?
And also that you're all pretty much tutoring, right?
Yes.
TAs.
Yeah, I can definitely discuss that. I've gone there a few times. I struggled at first with time management just because, as I said before, I'm in quite a few programs here on campus. So I went to the Center of Academic Achievement, and that was where I got the idea to do some scheduling and things like that. And it really bumped up my grades. My GPA is much higher now. And just kind of having that support from there as well, it makes it a lot easier. So, and as well as tutoring hours, I'm a TA, a grader, and a tutor on campus as well. So
you're returning the favor that somebody did for you in the first year, right? And helping other people with the same kind of issues.
Yeah, absolutely. And I have a great time. So,
Michelle, do you want to talk about that?
The CAS, yeah. So the Center for Academic Success, they have a lot of different programs for different classes. And I know at other schools, oftentimes it's only introductory classes that there's tutoring offered for, but each department sort of sends its, I guess, best students, if you will, for even the upper level classes. So I'd say that a lot of the students, I feel like most of the students who utilize the center are actually pretty academically successful overall, and sort of fine tune those classes that you're having difficulty with, which makes it a more accessible resource for everyone. So even though I'm overall like doing okay, I'd still go for, let's say, my thermodynamics class that I'm currently in right now, because a lot of the subjects are difficult, and especially for someone who needs to keep their GPA up. It's not necessarily want anymore. If you want to go to Columbia or an engineering school with the program, then those become like pretty necessary, I'd say.
John, do you want to pitch in? Or I think this question, Harim, is for you. The question says, can you tell me why you believe a 3-2 program at a liberal arts school may be a better option than going to an engineering school, such as Stevenson or Clarkson, if ultimately my son wants to be an engineer?
Oh, it's the communication, 100% the communication. The people that I interacted with at Columbia, the other students that I ended up meeting had that started there and were at the same level as us, considering I was a mechanical engineer. Their communication skills were really bad. Like, they didn't know how to present. They were always
struggling.
Yeah, that's the best word for it. They were always struggling with like class presentations, or even like informal meetings where you're just trying to explain the practice. Because if you want to be an engineer, I'm an engineer now. I work for General Motors, and the main thing for us is, especially with this whole virtual thing, is communication. If you can't communicate what you're doing to your coworkers, you're not going to make a good engineer.
So I think that's probably the best explanation of why a liberal arts. So remember when you were applying for jobs and they knew you were a 3-2 person?
Yeah.
They automatically assumed that you knew more than other engineers.
Yeah, because the field is so competitive now that having an engineering degree, even from Columbia, will not guarantee you a job. So having that second degree, especially from a liberal arts school where they know I've been taking all these random classes that normal engineer students definitely don't even look at, you know, it definitely helps that.
So like, for example, I can give you an example of my second son. I'm trying to convince him to go through the same 3-2 program, except I'm saying, you can do it in 4 years. It's okay. You don't have to do it in 3 years. But yeah, like, honestly, like, I think this is like my personal experience with putting my own kid through this. And I think he came out much better than you would have gotten as a straight engineer. Not that I'm saying anything about the engineering schools. I'm just saying that this program is good for my kids, right? And so the second one is probably going to do the same thing, you know? And so I have seen the difference in this person from 10th grade to now. And that's like really good. So I can as a mom, as a parent, can tell you that my second one is probably 99.9% going to do the same thing.
I jump in here with one other thing. In addition to everything that's been said, I think it's important to add that the quality of the technical education that students come out with here is very high. We've had students go into the 3-2 program and go off to Columbia and report back that compared to the other students who've gone through strictly engineering programs, they feel extremely well prepared. I'm thinking, for instance, of Annie Loliger, who reports that, you know, the other students have been coming to her for help with their courses.
And you got hired as he was a mechanical engineer and convinced the civil engineering department to hire him, just because he knew how to talk, right?
Yeah,
not that you knew anything about civil engineering. So that's all.
He did.
2 weeks into the campus, I got a job at Columbia at a civil engineering lab, which I ended up taking for 2 years, and that helped me. I think that was one of the biggest advantages for me. Besides all the classes and everything, for me getting a job, that was definitely one of the top ones.
Yeah.
And I don't think I could have done that without this previous experience. Like if I just jumped into an engineering school, I doubt that I would even look at that as a job, and then I doubt that I would be able to get what I would out of this program.
Yeah. So I hope that answers that question.
I think also the other thing is that, you know, if you go to Columbia, I don't know, Hareem, how big is the intro physics class in Columbia?
Is couple hundred.
Couple hundred, right? Whereas intro physics is 28 here, right?
At most.
Because you don't even
think the biggest, actually, Bill, I think you have the largest class on campus, and it's not even that large, right? Oh, I mean,
yeah, I used to hold the record for teaching the largest class on campus at 52 for introductory Gen Chem. It's been since then.
No way.
I know. Since then, we've got it down to 42. So I think that's still one of the largest classes on campus.
Split it into two, guys.
So, and even with 42, I can tell you that that you don't get lost in the numbers here, and I think that's what they're getting at, right?
Yeah, absolutely.
My average class size at Columbia was about 70.
Yeah.
Even in my majors, because I was a mechanical engineer, and that's the most common major. So I usually had classes between 50 and 70 people.
Yeah, at a school like SU, it's impossible to get lost in the shuffle. Like, number one, there's going to be no class. Every class is taught by a professor. There's no graduate students teaching anything. You know, the other thing is that because we're smaller, you have access to so many more opportunities, right? Like if you want to do research over the summer, if you want to get a job tutoring for the department, if you want to take an independent study in a class that you just think is interesting but is not being offered this particular time, those things are available to you. Whereas, you know, if you're one of, 300, you're just not going to get something like that at another school. So.
Or like in our thermal class, we usually wait for people to show up, right? And I'm like, okay, somebody text, XYZ that they're not here yet. Where are they?
Yeah. Why don't we keep moving, because I see a couple more questions floating in here. Okay. Michelle texted that in there, but just to reiterate here, does the 3-2 require separate application? Not to SU, but when you're done, like your final year here, you will apply to Columbia or apply to WashU or apply to Case Western.
Yep.
And we do accept AP credit. You need a 4. Is that
4?
That's right? Yeah, you need 4. And there should be information on our registrar's websites about what classes you get that you get credit for. So yes, you do get accept AP credit.
Actually, I'll jump in here and mention that in at least in the math department, if you get a 5 on the AP BC calculus test, not only will you get credit, you'll actually get credit for 2 courses. It's worth 8 credits.
Wow.
No,
If you
we'll shake his
where
head.
typing in the chat, make sure you put to all panelists and attendees. Otherwise, I don't think they can.
Oh, the attendees.
So generous in the math department.
Yeah, I know.
I will say that we haven't. Oh wait, sorry.
Go ahead.
I was going to say we haven't talked about. I'm not sure if there are any math majors here, but we haven't talked about the math hierarchy. I think we talked about chem, physics, and computer science. So if you want to speak on that, Dr. Wolf.
Well, I guess that's me. So yeah, I mean, the math major starts typically with Calculus 2. We have sometimes majors who start in Calc 1, but you get credit towards the major starting in Calc 2. The other basic courses are linear algebra and the introductory statistics course for the math majors, Math 180. And then after that, most students would take discrete structures, which is sort of an introduction to the logic and set theory that you need for the more advanced courses, and maybe Calc 3 differential equations and so on. And then there's a raft of upper level courses, including real analysis, complex analysis, abstract algebra, the last of those being a major requirement. And the other two are electives. There's an advanced statistics course that's an elective. There's a topics course that alternates with the advanced statistics course and advanced topics course that changes its focus every time it's offered. So that's roughly the structure of the math major.
And just to jump in a little bit, right, with the physics requirements, you need one extra class to get a minor in math. So.
Yeah. And actually go ahead. Yeah. I also wanted to mention that the, it's sort of another little inducement. The mathematical physics course that Carl talked about also is soon going to be cross-listed as a math elective. So we're very encouraging of physics majors to double major in physics and math.
I think that's also kind of a theme across the board at SU, that there's a very interdisciplinary nature of a lot of our stuff. One of the aspects of the central curriculum is interdisciplinary. So, there's a lot of kind of crossing over between majors and other courses and things like that.
You want to say something?
Yeah, it's also pretty easy to get minors in one of the other majors just because you do so many classes in the other one. Like I was a physics major, but I was one class away from a minor. So I took discrete structures and I got the math minor, which is super simple.
Which looks good on your CV.
It does. Yes.
You're a mechanical engineer with the physics and a math and a blah, blah, blah,
It starts to add on and you don't do too much work to get to the next step.
So that's good. If you want to be a physics, math, etc. teacher, can you add an education double major? The answer is yes. You can do a secondary ed major. That is pretty simple to do. As a physics teacher, I also believe that you can, as a physics major, a lot of our students have actually gone on to high school teaching. And within 3 months, they have to pass an exam or something, right? And then they become officially physics teachers. So both of those options are open. So anyone can jump in and become a physics teacher. I think correct me if I'm wrong, right? They only have to take one more exam, right? Alex, am I right?
Oh, so I think what you're describing is a situation where somebody has not gone through the education program but wants to take up high school teaching.
Yeah.
There, yes, the state offers a sort of certification exam which you would have to take. The way the sort of mathematics secondary education program or any of the other secondary education programs work here is you major in the discipline you intend to take, or intend to teach, and you simultaneously get an education major. It's actually kind of a heavy load because the final semester of the education major is devoted to student teaching. So you really have to get all your coursework into 3.5 semesters. But it does lead to automatic certification, and not merely that, but you will have had a semester of actual on the sort of on the ground teaching experience as a student teacher. So that's how that works.
I wanted to pose to all of our panelists, just for students who might be wondering what they would be doing in a lab class. Can you guys please speak on a little bit more of that, please?
So we
I
have,
can't.
well, Bill, do you want to start with chemistry and then we'll go back to physics?
Sure. So a lot of it, I think that's a pretty broad question, right? A lot of it depends obviously on the class that you're taking. But for most of our majors, most of the classes involve a lab as a component of that course. Sometimes that lab is not necessarily a separate course that you sign up for, but your grade is kind of woven into your lecture grade. And for some other courses, the lab is a completely separate course in which you get a completely separate grade. It just depends on the particular class that you're taking at the time. From the chemistry side or biochemistry side, or you are getting basically hands-on training in the specific discipline that you're taking at the time, be it general chemistry or organic chemistry or physical, where we are exposing you to to good lab technique so that your technique grows from semester to semester, so your ability to actually do work in the lab gets better. We are also exposing you to as much state-of-the-art instrumentation as we have available in our department. So all of our departments have access to a variety of pretty top-notch instrumentation. Because we're an undergraduate-only institution and we don't have graduate students, all of our instrumentation is handled by undergraduates. So we train undergraduates in both the use of and the interpretation of data that comes off of all of our instruments. We teach students how to not be afraid to touch the giant expensive thing that they might be worried about touching. And we encourage them to do that, because that's what you get when you come to an undergraduate institution only that has really good science programs, is that we try our best to show you all the things that all the big schools have. We have a lot of that same stuff. And the difference is that you actually get to touch it here. Like, you actually get to get in and get your hands on it. You don't have to stay behind the glass and not go near it. So we do a variety of things in the chem lab, from synthesis, making molecules, to studying them, to examining them, to computational work, using computational programs to model chemical reactions. So we run the gamut in chemistry. And in some of our upper level chemistry courses, there's a nice overlap between chemistry, physics, and math in terms of the kinds of things that we do in the lab. And also that translates to research for students that are interested in doing undergraduate research. Obviously, that's an added bonus to the lab time that you get. But our students, because we're ACS, American Chemical Society certified, our students are required to take a certain number of lab hours as part of their degree. And we leave that lab hours in the dust, where the minimum number is, we offer way more than the minimum number of lab hours. So our students come out well prepared. Even if they just want to go get a job when they graduate, they come out well prepared with the technical skills that they need to be successful. And I think a lot of the other departments will say the same thing. But I'll allow some of the other departments to talk about what they do.
So in the physics department, we have 3 major kinds of labs. One will be like the labs that you take in your first year, which include like independent thought and digital and analog, which the entire lab itself is the course, and you do all of the things together. Then we have some classes like Intro 1 and Intro 2 that have structured labs and lectures that are separated, usually taught by 2 different people, right? The labs will be taught by one professor and the lecture part may be taught by another one. And then we have upper level classes where the labs are sort of have a separate timing from the lecture, but it still is very hands-on, and it's very, you do the stuff, right? You develop the labs, you do all of the work that goes into the lab, whether it's a project that you do for the entire semester, or it's multiple small projects that you may do over the course, like in modern or something. So it depends on what kind of a lab that you want to think about. So we have so you will get to experience lab at multiple different levels, if that makes sense, right? Some of them are going to be completely hands-on, like your initial ones, where we sort of show you the ropes and how to start thinking about things. And then you have structured labs, which are proper, like intro physics labs. And then you have do whatever you want labs, well, not do whatever you want labs, but in a confined area.
Yeah, I always contrast this with like, they're not cookbook. Like, it's not like you're following do this, then do this, then do this. It's more kind of in the style of like a research sort of lab where you're developing your own procedures with the equipment that you're provided, that sort of thing. So that not only, you're not just like, reading these, detector data out and then you're just, writing it up. It's more like you're actually trying to come up with a procedure to figure out, develop your own sort of experiment. There's also, just to put another plug in for math physics, that there's also sort of a numerical kind of lab. So there's we have a lab once a week in that class where we spend time just learning how to program in MATLAB. And so, oftentimes, I'm sure Harim can say that like there's really only so many things that you can do on pen and paper, and it's sometimes you just have to throw a problem at a computer and let that solve it for you. And so, at least in this class, we try to give you some of that, using computers to solve real problems, kind of similar to how Bill was talking about, some of the programming stuff with Gaussian and modeling and things like that. So lots of other sorts of, not just hands-on, but, using technology also to solve problems as well.
E&M does that too, right?
Mm-hmm. Yep. E&M and math physics, both
math physics, both of them do that. Which works out really well, right? Because it's one after the other and it builds on each other. So we have a lot of things that build on in our curriculum on each other, right? So you'll take this one, which builds on the next one, which builds on the next one, which is very annoying for my students sometimes. Do you remember hearing about this in that class? And sometimes they go like, no. I'm like, yep, you did. You just don't remember.
I can speak on this as a student as far as the labs. So I've taken obviously some chem, bio, and physics labs, and they're all very different. Chemistry, obviously, you're most of the time dealing with chemicals and they can be dangerous. You have obviously like a written procedure. And then biology, sort of the same thing. Whereas physics, they let you play around with a lot of different stuff. The labs are stocked with all different types of materials. Sometimes there's like toy cars in there. You never know what you're going to find when you walk in. But I guess the point is to be sort of creative. So there's a lot of creativity allowed in physics labs, which I enjoy. But I recently started tutoring high school students and I saw what their labs look like, which is sort of like online modules. And you don't have to worry about that here. So I can sort of speak on that if you're in person for the hybrid semester, you are still able to use a lot of the lab equipment. There's obviously capacities for rooms. You might have to go into your lab in shifts. So your partner might come first, you come later, so you're not sort of in there at the same time, but you are still getting that hands-on experience, which I think is really helpful and a benefit to being fully online. And then for the students who are fully remote, a lot of the times there's cameras in the rooms that sort of show you what the experiment looks like. So you'll be working with an in-person lab group if you're not here. So you're still sort of also getting that experience, even if it might not be directly hands-on, but it's not like full online, like here's a picture of what the lab looks like, answer some questions. You're still sort of expected to get that experience or at least be attentive to it if you're not here.
And I want to pose one final question to all of our panelists. So for our professors, if you could share why you love teaching at Susquehanna, and for our students, if you would like to share why you love Susquehanna.
I guess for me, it's definitely, I like the fact that this school is kind of a small community. Like it's so easy to get to know your students very well. We're always, when we're allowed to see each other, we always have our doors open. People can come into our offices. I think the community aspect of our departments are really important, and I think right from the get-go, I think like our first years, jump in and get to hang out with other students and really know that like at any time you might be taking intro with me, but you could walk into Dr. Zain's office and ask her a question or something like that. And you know, or walk into the physics lounge where you might have, you know, students that have already taken intro or a couple years ahead of you, and you know, they can help you out. So I think that the community close-knit aspect of you know, being able to run through this major, you know, not alone, and you know, and have that shared experience makes it more exciting, I think. So
I think can I also extend that to faculty community? So just to give you guys an example, I'm writing a textbook as we speak, and I'm working on chemical thermodynamics, and I'm working on chemical potentials, and I couldn't explain it to the best of my ability. All I had to do was pick up the phone and call Swarna and say, hey, how do you define it in chemistry? You know, and so just that little thing of the camaraderie in between the faculty, where you're okay in asking, I don't know how to say it, can you please help me, right? You know, with whatever problem I have. I think that's sort of something that only a small community could do. Like bigger schools where everybody's siloed may not happen. It doesn't happen, right? I mean, where you are so comfortable going to a math department. Like I go to the math department so many times. Okay, I have no clue what I'm doing. Can somebody please help me with this problem? And the fact that like everybody is helpful. Like I'll go to Carl, or I'll go to, you know, Jen, or anybody, right? You can go to people and ask for help. And sometimes like you guys are sort of like my guinea pigs for working on the textbook, right? You read it, you come up with, you know, mistakes, and there's a minus sign missing, duh, you know, like that sort of thing you will not find, I don't think, in a big school. No. Like that comfort level of me being able to say, I don't know something as a head of the physics department, right?
Can I jump in and add something that I think kind of goes along with that? Another thing you won't find at a big school is a lot of variation or experimentation with the material and with how to present the material. At a large school, especially one that's, for instance, serving a large engineering program, a lot of the physics courses, I know a lot of the math courses, are taught in a very rigid way. And there's no wiggle room at all. Here, the faculty members are really free to develop their own courses the way they want. Anybody who's been teaching at a college level for almost any length of time has, you know, inevitably they develop their own ideas about how they'd like to say things, how they'd like to present the material, in what order, what little insights they would like to bring forward. And at a large school, you can have those ideas. That's well and good. Keep them to yourself. Here, they can live, and I think that's one of the really great things about teaching at a small liberal arts college. Actually,
that was actually going to be one of the things I loved about teaching at SU for me, is that I'm feel comfortable experimenting and trying different things, which is nice, because when I was an undergraduate, I did go to a large engineering school, and there wasn't a lot of variety. I did not know most of my peers. You know, there were 60 of us in the major each year, and there just wasn't a lot of support, and I felt like a lot of the instructors didn't have a lot of support, not just from each other, but from the administration. That's not the case here. There's support all around. We're given the tools we need to succeed. We're taught how to use them as needed. And I just feel supported. Just nice.
Yeah, unlike Dr. Carter, I actually am the product of a liberal arts education, right? So I went to a small liberal arts school for my chemistry degree, and I knew that if I was going to teach, that's the kind of environment I would want to teach in. I did my graduate work at a large institution, so I got to see both sides of the same coin. What I could echo what everyone else is saying, but to add, what I like most about teaching at SU is the chance that I get to marry what I do in the classroom with what I do in the research lab. So this idea that we can marry together our scholarship, the stuff that we are interested in doing, the stuff that we research on our own time with our students, because a lot of us do research with undergraduate students, and how I can bring that together with what I teach in the classroom. This idea that we can marry those two things, that we don't have to silo them or separate them and say, well, here's what I do in the lab and it has nothing to do with what I teach in class, right? And if you're at a large institution, you tend to be focused on one thing or the other. You tend to be more teaching focused, or you tend to be more research focused, and very rarely at large schools are you equally focused on both. And I think at SU we are not only encouraged to be equally focused, but also to find ways to involve students whenever possible. It's not always possible for every major, but for a lot of the majors on this call, it is. And we try to make use of incorporating students in that. And that's one of the things that I like most about teaching at a school like SU.
In terms of student life, I can agree with a lot of what the faculty is saying, is that there's a sense of small community in the school. And I can sort of say that just because my main friend group at Susquehanna were music, art history, and museum studies majors, which is kind of weird because I'm a physics major, so you'd think we'd all be sticking together, but we really don't. And that's something that I took for granted until I went to Columbia, and then I realized, oh my God, all of my friends are engineers, like literally all of them. I don't have a single non-engineering friend. And it's just, sometimes it's just nice to put all the software and all the pens and paper down and just talk about something else, you know? And that's something that I had at SU that I didn't realize I had until I went somewhere else.
Also, your artwork in your dorm at Columbia was a hammer.
Yeah.
Pinned to the wall. Yeah. Honest to goodness, it was a hammer taped to the wall. That's how nerdy they are.
Yeah, that's what you get when you have 6 roommate engineers.
Yes.
I want to thank all of our panelists so much for your time and for sharing your expertise and more about the programs in which you teach and what you've learned. Please feel free to reach out to any of them. Panelists, if you want to leave your email address.
Yeah, through my email in the chat. I think maybe if you guys all do that as well, that might be
do that too.
So they can
that would be great. And I just also want to let all of you attendees know that Susquehanna is open for visits. So if you would like to visit campus, that is an option. Our website is susqu.edu. So please feel free to visit us. And we also have virtual information options as well that you can take part in. But I just want to thank all of you for your time. Thank you for tuning in. And we hope that you apply to Susquehanna, and we hope to see you in the fall. Thank you and have a nice evening, everyone.